Good morning, Morgan. Excuse me. And good morning to any of Morgan's friends that have joined the video today. We finally get to start learning about classes. Okay? Unfortunately or fortunately, depending on your perspective, we're going to have to get through about 3 boring videos that will lay the groundwork for what's to come. Okay? So it's not going to be until video 59 that we actually get to do some coding so that we can show you some examples. In the meantime, we're going to have to do a bunch of reading because you guys have such a short attention span. That's why I've broken it up into 3 pieces, okay, so that it hopefully it'll stick better. Anyway, with that, let's get started.
Python TV56. Classes. Classes provide a means of bundling data and functionality together. Creating a new class creates a new type of object, allowing new instances of that type to be made. Each class instance can have attributes attached to it for maintaining its state. Class instances can also have methods, defined by its class, for modifying its state. Compared with other programming languages, Python's class mechanism adds classes with a minimum of new syntax and semantics. It is a mixture of the class mechanisms found in C++ and Modula 3. Python classes.
Because you guys are young and just starting, I'm sure none of you have experience with C++ or this other language. And guess what? It doesn't matter because they're freaking obsolete. So don't worry about it.
Python classes provide all the standard features of object-oriented programming. The class inheritance mechanism allows multiple base classes. A derived class can override any methods of its base class or classes, and a method can call the method of a base class with the same name. Objects can contain arbitrary amounts and kinds of data. As is true for modules, classes partake of the dynamic nature of Python. They are created at runtime and can be modified further after creation.
Okay, there was a lot there in that little paragraph, but I want you to focus on the idea of hierarchy. Okay, and you saw a hint of that when I showed you the hierarchy of the exceptions in that little diagram. Okay, there's a boss one, and then somebody underneath, and then there's a couple more underneath it. Okay, and that's what I want to point out. The other stuff we'll reinforce later.
In C++ terminology, normally class members, including the data members, are public, except see below private variables, and all member functions are virtual. As in Modula 3, there are no shorthands for referencing the object's members from its methods. The method function is declared with an explicit first argument representing the object, which is provided implicitly by the call. As in Smalltalk, classes themselves are objects. This provides semantics for importing and renaming. Unlike C++ and Modula 3, built-in types can be used as base classes for extension by the user. Also, like in C++, most built-in operators with special syntax, arithmetic operators, subscripting, etc., can be redefined for class instances.
Okay, in this paragraph we're talking a lot about all these different languages that sadly you are going to have some exposure to, but you don't really need to learn them because what you're going to find out is they're very, very similar to Python, except Python isn't as complicated as these other languages are. So you're going to find in the future that what takes 1 or 2 lines of code to do in Python takes 5 or 6 in these other languages. Okay? And with that, let's finish up this reading.
Lacking universally accepted terminology to talk about classes, I will make occasional use of Smalltalk and C++ terms. I would use Modula 3 terms, since its object-oriented semantics are closer to those of Python than C++, but I expect that few readers have heard of it.
All right, well that's it for today's video. We've got 2 more boring videos to go. and then we can go and start having some fun. All right? All right. Enjoy your day. See you in the next video.